Welcome to solving compound inequalities. Compound you hadn't done before. This is where we're going to have different parts to our inequalities. So first, let's focus on what is called an and inequality, and then second, we'll take a look at what it means to have an or inequality. So an and inequality is going to combine two types of things. First, let's look at this. We're going to do x is greater than -3. I'm going to look at this one and pick a number for it. I'll put 0 here. This gives me -3 here. So that means it's greater than all the numbers that are larger than -3, but not including -3. Then next we're going to graph x is less than or equal to 2. So again, I'll put 0 here, we'll go to 2 here. It's equal to, and it is less than. It's all the numbers that are less than it. What I want you to see, and I want that to continue a little further, we're going to put them together. Here was -3, 0, and 2. So -3 is going this way, 2 is going this way, and it's really that they're going towards each other. For the context of these problems that we're having these inequalities together means that we aren't going to go past them and do like all the numbers down here for the 2 and all the numbers up here. Instead, what we're looking for is what areas overlap, and that's what you do with and areas. So it's this key word is overlap. So here on this one, there's our overlapping area. And let's put that into where there's an x in the middle. X is less than 2, or it's equal to because it's filled in, but it is also greater than -3. I'm going to put that into these brackets. That shows the answer type of the way this should be answered. Okay. So in and one, we're looking at the overlap area. For an or one, it's going to be a little bit different. With an or one, we're going to do first x is less than -3. So let's say we put the 0 here and the 2 here and 3. That means it's this number and all the ones before it. And then here we're going to look at x is greater than or equal to 2. And that means it's a filled in circle. And there. So in this case, the answer can be any number that's here, or it can be any number that's here. It'll make them both true. It'll make one of them true. So I'm going to write that for the answer as x less than -3 or x greater than or equal to 2. It's sometimes shown with a comma between them, but I would prefer not to do that. Not preferred. So instead, we do it with the or statement, and actually this element or. So let's take a look at solving a couple of these. These are and statements. And we see right now the x is in between these. So you have two ways to do this. You could separate this right now as like not include that and do 26 less than 3x plus 2. And then you would afterwards do away with this part and you just do the 3x. 3x plus 2 is less than or equal to 35. Now that's true, you could do that. I'm going to show you a different method, but I'm going to keep them as three things here. In fact, I guess I'll just write it out. 26 less than 3x plus 2 less than or equal to 35. So what I'm going to do is work like I normally would to solve an equation, but now I'm going to be doing it right side and on the left side. So I'm going to do both of them at the same time. So that leaves us with 26 less than 3x less than or equal to 35. Oh no, that's 33. That's wrong. So now that I've gotten to, oh, in fact, I did this one too. I got 26 without putting a second thought. What is 24? Now let's divide by this 3. And that gives us that 8 is less than x, which is less than or equal to 11. Well, and that gives us a good answer here. Now, if I had done it, and in fact, I'm first going to do this. Take that 8 together. I'm going to mark this. Well, let's say if I had done over here in the blue, if I had done these differently, and I did them as separate ones. So 26 take away 2 is 24 less than 3x. Divide by the 3, and x is greater than 8. So I'll take it as x greater than 8 and switch it around this way. That was true. That was this part here. Here on this one, I'm going to subtract the 2, and we get 3x is less than or equal to 11. And then I'm going to divide by, oh, not 11, 33. I'm getting ahead of myself here. So I know that once I divide by 3, I get 11. X is less than or equal to 11. Only positive 3, so I don't reverse the inequality sign. So now I would graph those two, but if I graph them, I would end up getting the same answer as this, because I would do, let's say, here's 0, and here's 8, here's 11. So this is the numbers greater than, this is the numbers less than, but the places where they overlap is here. So that's why I could put x is less than, and it's equal to 11. And on the other side, and we know with the 8, well, it's x is greater than 8. So it's, oops, that means it's this going this way. So we have this overlap to work with. X is between those. It's between the 11 and the 8. And for some reason, I realized I put a negative there. It's not, let's make sure that it recognizes that's positive. Sorry for the sort of type. Well, I didn't want that. Have that go there. Just want to get the last little bits of yellow. There, now we got it. Right. Now I just realized this other side over here. See, there's only one difference. Look at that. This is going to illustrate a big thing that I need to point out. One place where people tend to get this wrong. So let's watch this very carefully so you don't get it wrong. I'm going to subtract the 2 on all sides here. Gives us 26 less than 3x less than or equal to 33. Just realized I did it again. I have some mental block just of actually doing subtracting 2. Now I've got it. Now I'm going to divide by the -3 on sides. So I get a negative 8. And I get a -11 in x, but I need to reverse the inequality signs because I'm dividing by a negative. So I get that, and I get this. Okay. Now, if I do this and say that's the answer because there's nothing to add or subtract from there. But if I try to do this as the answer, it's wrong. because negative 11 is not smaller, or is not larger than negative 8, and that's up our right side. We in our culture go from left to right for either like reading things or getting larger, things getting larger. Over here, things are getting smaller. So what you need to do is you need to switch them, switch the order of them, and keep the relationship towards the number and towards the x the exact same. So that means x is greater than or equal to negative 11, which we had over here. And it's also less than negative 8. Okay, so the reason I did that is because this is now in keeping with the normal number line. That's negative 11, that's negative 8, somewhere down here, negative 0. This kind of thing is like showing that there's condensed space in between them here. Because there would be, 0 to negative 8 should be a little larger than that. But now, this is showing that x is between these, and it's less than the negative 8, but it's greater than and filled in the x. So x is any number that's in between those two, but it has to be in the right order. Okay, so remember that there. Now these are and ones. And ones have the overlap. Now let's solve an or one where the results of the inequalities go in different directions with the overlap. So I'm going to divide by the negative 4. Doing so, x has to become less than the negative 3. So it changed there. Or, well, now notice if you have a paper for this and it has plus 10, it's been changed to minus 10. So I'm going to subtract the 3x. And I'm going to get negative x less than negative 10. Let's do, we can't just take away the negatives. We actually have to divide by a negative number. So here I get the x, but then this changes to greater than approximately 10. Okay, now let's take a look at this on a line. Okay, we have 10 out here, 0 here, negative 3 here. So less than are all these numbers that are less than negative 3, and then all the x greater than 10, it's all the numbers greater than 10. So we actually have 2 of them. We can't put it like here, where we put the x in the middle. Okay, so that's a perfectly fine thing to do. Oops, I just realized I could double this. So I'm going to do that. Then we're going to go back. So instead of overlapping, it's going to be like these other two problems. Let's see. It's going to be that they go out from each other. So here, the x value is less than negative 3. Here, the x value is greater than 10. So the way we do that is we say x less than or equal to negative 3 or x greater than 10. And the or is a pretty important part of this. So let me do this one. So notice the difference in the answers. These, the x is in the middle of them because it's where the two things overlap. And here, if x is one of them or the other one. So a correct answer could be a negative 4, even though it doesn't work for this one, it does work for this one over here. Or the answer could be 11. 11 works here. It does not work over here. These are a couple of practice ones to do. Okay? So let me go through these. In fact, this would be a good time to stop watching the video and go and do these problems and then come back to it. I'll start talking in about 3 seconds for anybody who's come back from practicing them. Okay, so let's do this. First, I'm going to do the +3, which means I'm going to do it for all three parts here. And that means I get a -5 less than or equal to -5x less than 10. Well, I'm going to divide by the -5. So we get a 1 here. But because I'm dividing by a negative, I have to change around this. So the negatives and 5's cancel. I get x, and I get greater than -2. Oh, now, wait a minute. We have to look at what this means separately. So we're going to need to do this and then this to graph it, because you realize this cannot be the correct answer. It is the correct answer in a convoluted math way, and we have to change it back to the way it's supposed to be. Okay. So if I put -2 here, here's what 0 was, here's what 1 is. And so this is saying that x is less than the 1. And greater than the -2, but not equal to. That means the answer is in between these. So I have x less than or equal to 1, greater than -2. So for these, to have them correct, okay. Oh, it's not going the way there. Sometimes if I move it slowly, it still works on it. All right, there we are. So that illustrates when the x is between them, that means that this is an and statement. So the other one actually says it will be. So let's solve these. So I'm going to add 42 to both sides. Well, I don't need to. I don't think I even need to do that because it's only one set of numbers. So I could, but actually we'll just slow the problem down. Let's move the x's. We get -42 greater than or equal to 6x. And now I'm going to want to divide by the 6. And that gives me -7 greater than or equal to x. And on the other side, the other one, well, let's see, let's subtract 7x here. And that's 5x greater than 65. And then divide that by 5, and we have that x is greater than 13. Now, we don't have to draw a number line, but it does help often to see it. Here's -7, 0 here, and 13. So this one's going to show less than or equal to the 7, and less than is all these numbers. It's -7. And here it's greater than 13. So no one notices that one yet. Now we see that x can be any of the numbers over here, or it can be any of the numbers here, and it will make the statement or the other true, whichever one it fits with. And we show that as x is less than or equal to -7, or x is greater than 13. Okay, and showing what the correct answer is here. So these are good practice, and remember where the inequality signs go, and if you have to reverse them if you're multiplying and dividing. So what we had here was solving these compound inequalities, which they are, and overlapping areas or not overlapping, going out from each other, not to have said goodbye either. And that tells you that it's probably an or statement. Okay, and statement. Well, I hope that helps with doing compound inequalities. Thank you for watching and listening.